Okay, let us now focus on energy since we've seen what work is. So, energy is the measure of the body's capacity to do work, as simple as that. It has a very simple definition. It is a scalar quantity and the SI unit is a joule. So, work, energy, both are measured in joules. A body possessing energy can do work and it loses energy. So, when the body, whoever does work, loses energy, and whoever the work is done against gains energy, as simple as that. Work done is equal to change in energy. So from there, let's handle now kinetic energy. This is the energy possessed by the body in motion. So it's the energy. Whenever a body is moving, it should be having a certain kinetic energy based on its mass and then its velocity because it's in motion. And the kinetic energy is given by this formula, a half mv squared. So potential energy, for it is the energy possessed by the body due to its position. P of the body of mass m and distance h is given by, now we have two cases. When the body is above its initial ground, above it, so it's always positive. When it's below the initial level, then it's negative. P at the initial level is always 0. Let us say conservation of energy. Conservation of energy, if a body moves without doing work against friction and gravity is the only external force acting on it, the sum of the body's kinetic energy and potential energy is a constant, and that constant is called the mechanical energy of the body. So therefore, mechanical energy is given by the sum of the potential energy plus the plus kinetic energy. Note, mechanical energy can be lost in the form of sound and heat energy. So heat energy, when there is an impact, there we can lose some energy, and then when we sound, when you are pushing something against something, there is that sound that is made, and there we will be losing some mechanical energy. Note, the mechanical energy of the body is conserved if gravity is the only external force acting on it. But here it can't be conserved when you lose it in terms of sound and then heat. ME, mechanical energy, can't be converted into other forms. So that's where the energy is conserved. When you can convert to other forms and when it's only gravity which is acting on it. But the moment the mechanical energy is converted into sound and heat, there that means that we cannot conserve it. I.e., Pe plus Ke is equal to constant. So this means loss in mechanical energy is equal to the gain in potential energy, and loss in potential energy is equal to the gain in kinetic energy. From there, we have now the work energy theory. This is interesting. This states that work done by a resultant force acting on a body, I think we know what resultant force is the sum, is the total energy being applied on the body from all the forces acting on that body. If you have a force beside, and then the force beside is a resultant that is acting on that body, which is the sum of all those forces. So when that resultant force acting on the body is equal to the change in the kinetic energy of the body. Now, you know that our work is given by force times the distance moved. The work is given by the force acting on the body and the distance in which that body has been moved. We now know that our force from the Newtonian second law is equal to the mass times acceleration, I put it here. But you know that this one is now acceleration times the distance. Now from our third equation of motion, v squared equal to v squared plus 2as, we make this as the subject, so we shall take this side and after divide by 2 as you see there. So now putting this as into here, and then we open brackets, so that now a half of this is equal to that, and there you can see that we have a change in kinetic energy. So work done can also be got by getting the change in kinetic energy. But that we have already seen if you were keen from here. Anyway, let's remember now we are going to see some bit of examples, and then also we shall go to power. See you there.